Okay, let's move on to another mission. This is one of the orbiters, the MAVEN mission, which stands for Mars, Atmosphere, and Volatile Evolution. This is controlled by the Lab for Atmospheric and Space Physics up in Boulder. The spacecraft was built here at Lockheed Martin. And what the mission for MAVEN is to determine how the atmosphere has changed with time. So they're measuring the upper levels of the atmosphere and measuring the escape of the atmosphere from Mars, and then using that as a means of looking back in time to determine how the atmosphere has evolved. And this is sort of an interesting story that involves the Earth as well. Back in early September, there were a huge set of sunspots. So this is an image of the sun taken through a solar telescope. There's the Earth for scale. And there was a lot of concern that as this sunspot passed the center of the sun, pointed at the Earth, if it actually erupted into a huge solar flare, coronal mass ejection, that would be the type of thing that could cause very damaging radiation spikes on the Earth, in the sense of bringing down power grids, affecting orbiting satellites, things like that. That didn't happen. We got some really nice auroral activity out of it. But once that set of sunspots rotated around off the limb of the sun on the 10th of September, they finally erupted. And this is the solar flares happening. And this next image I'm going to show you covers about this area, and it's rotated by 90 degrees. So we'll see how that progresses. But up on this next image is off in that direction. So this is from the Solar Dynamics Observatory, and there's the coronal mass ejection happening, and you see these loops of plasma that are trapped in the magnetic fields. And what is unfortunate for Mars is off in that direction. And so it got blasted with this very high energy solar wind. And Mars doesn't have a magnetic field like the Earth does to protect it from these things. So MAVEN has an ultraviolet imager that is very sensitive to the wavelengths where you see aurora happening. And this is what Mars typically looks like, which is not much. There are only rarely aurora occurring. But this was on the 13th of September when the coronal mass ejection reached Mars, and much of the atmosphere started glowing. And this is actually 10 times the magnitude of any previous aurora that has ever been observed on Mars. And what got people's attention is the Curiosity rover also has a radiation detector on board. And it spiked to about 3 times higher radiation than the maximum that had ever been observed. And so that's the type of thing, if we had astronauts on the surface of Mars, you would be telling them to get underground or get into protected areas to avoid the radiation dose. So that was, the type of thing that they've been waiting and hoping that they would see on MAVEN. So they finally crossed that off their bucket list, but it was a very successful observation. And the thing to notice is, there's the North Pole, South Pole, and so the aurora are actually happening on the sun-facing side of the planet. the entire sun-facing side of the planet. And unlike the Earth, and this is a map for tonight, where this is the auroral oval, so we're looking down on the North Pole here, and on the Earth, that's typically limited to the polar regions, and that's because the Earth does have a magnetic field, and the field sort of descends toward the planet at the North and the South Pole. And so all these charged particles get wrapped up in the magnetic field, and they come down in the polar regions, and that's what causes the aurora. And so on Earth, it's a polar phenomena. On Mars, since Mars doesn't have a magnetic field, it's everywhere. And so that that was a nice result.